This is chapter 16, page 418. You need to know that ocean water is layered in distinct layers because of the sun's solar energy. It warms the surface water, and it's less dense than colder water, so stays at the top. And underneath that, there is a layer of cold, dense water, and it's also very nutrient rich. You also need to know heat capacity and currents. On the next page, this is a picture of the ocean's currents, but you just need to know the Gulf Stream. And the Gulf Stream is right here along our east coast. It pulls warm water up from the Caribbean and it moves it across here to Europe. So England here is pretty high in latitude. It's higher than Minnesota, and Minnesota gets a lot colder in the winter than Europe does, and that's because the Gulf Stream is moving warm currents across here to Europe. And that's really the only reason why people in Europe can live this far north, because of the Gulf Stream. The next page we're going to talk about upwelling, and it is referring to this California current right here. So page 422. Upwelling is very, very important. You need to know the steps in upwelling. There's wind blowing across the coastline from the north along California, and so water moves away from the coast. And because water is moving away, cold water from the bottom of the ocean can move upward and replace this water, and that's what upwelling is. Now the water here at the bottom is very nutrient rich because of the decaying or decomposing aquatic life. So it's rich in nutrients. So when it moves up, it's really good for producers like phytoplankton, because they have light and they have nutrients. So fish can come in and eat the phytoplankton, and then sharks and sea lions, and you get a very rich ecological life here. So upwelling, know the 3 steps of upwelling. It's very important. And know that most life in the ocean is near the coasts due to upwelling and in the photic zone because of photosynthesis. And the photic zone is where light can reach. Also know downwelling is the opposite of upwelling. And then thermohaline and ENSO. ENSO is El Nino Southern Oscillation, so refer to our lesson on that. On page 423, know the figure and the steps in normal conditions and ENSO circulation. And I will go over those briefly here. This is the west coast of the United States and Peru here, and this is Asia. So normally, and these are normal conditions, winds will move away from Peru and towards Asia. So there will be this pool of warm water and warm air here, and that will drive precipitation here. And that also causes the movement of water away from this coast, causes upwelling to happen here. It's very good for fishermen because fish are getting a lot of phytoplankton because of all those nutrients here. So it's very, very good, and that's normal. Every 5 to 7 years, though, these winds will weaken. And so the winds aren't moving this way anymore. They've weakened, and this pool of water, warm water here, starts to move back towards Peru's coast. And it takes a couple months to reach it. But as that happens, there's no upwelling, so there's no more nutrients here. So it's bad for fishermen because there's no fish in the waters anymore. And it also drives a lot of precipitation. So you have like a lot of rainy weather happening here along our west coast and along South America's west coast as well. So make sure you know that that's very, very important.